Hey, welcome to Live Code Tuesdays, our weekly live stream from Fermion. My name is Sohan Maheshwar. I'm in a new setting today, as you may have noticed, staying at my parents' house for the next couple of weeks. Also have Radu, our regular guest. Hi, Radu. You might be on mute. Sorry, that was my bad. Yes, there we go.
Hello.
And we also have a very, very special guest today. For the first time on our live stream is Thorsten. Thorsten, welcome to the show.
Hi, and thanks for having me.
Yeah. Already see some familiar faces on the chat. We have Holy Odin, who's busy with NSEM exams. Good luck for that, Holy Odin. Hope that goes well. We have Bunny again. Hello, Bunny. Nice to see you again. We have David, too, from Dallas. Yeah, I'm streaming from India, visiting the folks for the holiday season. So the plan for today, again, going to be, more of what we've been doing over the last few weeks. We're going to be talking about Advent of Spin again. Hope you've done the challenges. Last week we did challenge 2, so we will go over the solution for challenge 2. But before that, we're going to unveil challenge 3. So Radu, over to you to unveil the new challenge for this week. And
Yeah.
yeah, as Radu shares his screen, if you haven't already, Advent of Spin is a coding challenge for you to learn building on Spin and WebAssembly. Series of challenges, again, just to get you to build and deploy apps. Straightforward stuff. It'll be fun, and there are prizes to be won as well. So do check it out. You can check the link below. Radu, over to you.
Yeah. So if this is the first time you're bumping into Fermion's Advent of Spin, there's a GitHub repo, Fermion/Advent of Spin, where you'll find all the challenges from previous years and from this year as well. In a 2023 directory, you'll find the so far 2 challenges from this year, and Thorsten will walk us through solving challenge number 2. As we do every live stream, we basically unveil this week's challenge on the live stream. So we see a pull request open a few minutes ago by Mikkel. So let's go through the challenge, explore what's happening, talk a little bit about it, and then see. Actually, let's see if by the end we'll have people who actually submit challenge number 3. But yeah, so challenge number 3, for this challenge, you'll use the Spin CLI as usual, your favorite programming language supported in Spin. If you're curious, what are the languages that you can write WebAssembly applications in? We have a language matrix that we keep up to date with all the languages that support compiling to WebAssembly and the WebAssembly system interface. And then you'll also need to work with Spin's language model inferencing feature. Ooh, this is going to be interesting. So if this is your first time working with Spin, have a look at challenge number 1 from 2022, which is essentially Hello World. This year, the stakes are higher and the challenges are more challenging. The Fermion elves have decided to help Santa use serverless WebAssembly for Santa's new web application. Your task is to help the elves get the project up and running before Christmas Eve. The elves will hang out in the Fermion Discord server and can help answer questions along the way. If you're interested in joining our Discord server, there are more than 1,000 people on our servers. If you're interested in chatting about anything from Rust to WebAssembly to serverless, it's a pretty good chance to do that. Cool. Let's dive into challenge number 3. So the elves have noticed that we're suddenly almost halfway through the Advent, so things are becoming a bit hectic. One of the things the storyteller elves suddenly realized is that they haven't started writing the new Christmas stories for the year. The elves will need your help in writing, and there's writing in quotes, which is always a good sign. The elves will need help with writing the most exciting and engaging Christmas story of the year. Luckily, they've discovered the serverless AI feature of Spin, and they think that might be a good way of doing this. You can write your application in any language that compiles to WebAssembly, and you can use SpinU, one of the language templates. The elves will use a random set of words as an inspiration to your story, and it's up to you to figure out how you can prompt the language model to use those words to create the most engaging Christmas story. Hint, you can try to do a specific kind of style for your story: poem, play, short story. Who's the narrator? What's the language like? Funny, sad, Simpsons-like? The elves will post to / with a JSON object like this. And the sample data is basically telling you what the story should look like. So the place is the North Pole in this example. The characters are Santa Claus, the Grinch, and a penguin. I'll admit that I don't know what a penguin is. We'll get to that in a second. And then object, a spoon, 2 presents, and a palm tree. There are no requirements as to how long or short the story can be. When posting, the elves can expect an HTTP status equals 200 to be returned with your story and then text containing your actual story. And then it'll have to be JSON content type, and this is just a sample, so not the real payload that your application will receive. So unfortunately, it feels difficult. It sounds impossible for you to manually write the story, which is unfortunate. I think it would have been a nice, yeah. You can test using Hurl. By the way, shout out to the Hurl project, which is a really, really awesome way to test HTTP requests, to test your HTTP APIs locally on your CLI. You can test with the specified test Hurl script. And then to submit, you will also use Hurl and then send it to, submit that Hurl with your endpoint deployed somewhere publicly. You can easily do that with Spin Cloud Deploy. And then don't hesitate to reach out on Discord and then post your results on Twitter or LinkedIn or anywhere else you might do social media. Remember, there are prizes for each challenges. So if we have a look at the advent of Spin repo, we have a bunch of prizes for every challenge. So for challenge 1, we have the Spin Dead and Field bag. For challenge 2, we have the Fippy's Field Guide to the WASM Trail Map puzzle. For challenge 3, which is the one that we just looked at, if you solve that one and submit your result, you can get a Fermion Fanny Pack. And then I am most excited about challenge 4 for next week because I really want a Fermion. So if we go back through the challenge, the TLDR, as far as I can tell, is you'll receive a JSON object containing places, characters, and objects. And the challenge is creating a story in whatever style and however long you like that contains the place, the character, and the objects specified in the spec. And the hint here is to use the language model inferencing feature in Spin and Fermion Cloud to generate a story that basically contains these objects, characters, and places. That's going to be a fun read through the submissions. So that's going to be interesting. I'm very, very interested in if you solve this one, and if as you're testing this one, to post the intermediate results to Discord and just tag us into those, because I'm really, really curious on how that's going to look like. So
yeah, I think a lot of it will come down to prompt engineering, which I admit it's a lot of fun to do, right? Thorsten, you've played around with the serverless AI feature, I'm sure. Have you played around with like some prompt engineering? Do you have any tips and tricks for this particular challenge?
Well, yes, obviously you have to play around a little bit with prompt engineering, right? To put in some Christmas mood. But I mean, it heavily depends. We can leverage Llama 2 chat. So there is let's say a best practice how to format your prompt. So to divide, the system prompt, and maybe to treat a little bit with it. You can add like a memory to it. Maybe someone wants to extend or make his story even better over time. So this would make coming up with the best prompt like a journey, like maybe starting today, ending next Monday. So there's enough time to come up with a great story, or a funny story, whatever. So I guess we will we'll hopefully see a lot of stories in Discord that we can all read through, and maybe, tell me personally, I can tell them to the kids. So when I have to bring them to bed later during the week, maybe some good Christmas stories for them.
I have 2 more things that I wanted to show.
As Bunny says, go for it, Radu. Yes.
There are 2 more things that I wanted to show. I'm sharing my screen, I think. So first, we have to actually merge the pull request, so everyone can actually see it in the Advent of Spin repo. So I'm gonna approve it and then merge the PR, so you can find it in the official Advent of Spin repo. And then if you want inspiration on how to get started writing writing an application that uses serverless AI, we have an example repository that contains samples in a whole bunch of languages from TypeScript to Rust to Python on how to build simple endpoints that use the inferencing endpoints, both locally in using Spin and then deployed from in cloud that use Llama 2 Chat, what Thorsten was suggesting, that it would be a good fit to solve this challenge. So if you wanna have a kickstart on how to solve challenge number 3, have a look at this repo. With that, I think we're happy to answer questions about challenge number 3 in the chat. And I think we're ready to look at challenge number 2 and solve this challenge. And Bunny, Bunny asked earlier what a penguin is, and apparently it's a Hungarian for penguin. So I did not know that. Thank you.
Cool. So should
I
I
think
bring
it
up
also
my-
could be Danish for penguin, and given that Mikkel wrote it, so it could be Danish for penguin as well. We don't know. Holy Odin, about the Hurl thing, Thorsten will be showing us a demo of challenge 2 and how he did some very cool things with unit tests and Hurl and all of that. So stay tuned. We will be talking about that in a bit. Yes, Thorsten. Andrado, you've checked in the challenge 3, correct? We're good to go with that?
Yes. Yes, it's now in the repo. If you go to github.com Fermyon Advent of Spin, it should be in the challenge 3 directory.
Yeah. All right, so we are officially live, folks. Get cracking with challenge 3 after the stream, though, after the live stream, because Thorsten is actually going to show us how we, a great way to actually look at the second challenge, right? So the challenge itself has like some code component to it, which we'll talk about, but Thorsten did some pretty cool things with unit testing and, massaging the data around it as well, which I think you will like. So yeah, Thorsten, over to you.
Okay, cool. So let me bring up my screen.
Yeah, and in the meanwhile, folks, if you haven't checked out Advent of Spin already, please do so. Yeah, we are live.
All right, so you should see again the Advent of Spin repository right now. And with that, we jump right into 2023, and there we see challenge 3 is merged and is on head currently. But we will look into challenge 2, and as Radu already laid out, the entire tone of the Advent of Spin, we can jump directly to the spec, right? So let me quickly read through it so everybody could, follow along. So this time around, the elves need to help Santa prepare for his travel around the world with all of his presents. Now we are all used to seeing Santa taking off in his sleigh with a huge sack of presents, obviously. But we all know that it's absolutely impossible for all of the presents to be handed out to children around the world can fit in one load. So in reality, Santa obviously has to make multiple trips, but it's time consuming and the elves really want to help optimize the number of kids Santa can reach on each trip. Now travel time is not an issue for Santa with his hypersonic reindeers. So the main thing to consider is how do the elves load the slide, optimizing for the number of kids to reach given the combined weight of presents to a single house and the slide's capacity. You can write your application in any language that compiles to WebAssembly. To skip the boilerplate, use SpinU and use one of our language templates. The elves will use your application by calling the root of your application, giving it an array of how many kids are in a given house and to total weight of the presents of for those kids. Your job is to tell the elves how many of those kids that can optimally reach in one load. Okay, so there's a lot of information already in the last paragraph, right? So basically, we can leverage Spin, use our or preferred programming language, as long as it compiles to WebAssembly. And Radu showed already that comparison table where we can spot all the different supported languages. And so the elves will call into our app, and we have to come up with the optimal load for each trip. Okay, the body of the post call to / will contain a JSON object which can look like this. Okay, so again, some essential information over here. So we expect a post request to be sent to our API, and it will hit our endpoint at the root route, so to say. Then we see how the structure would look like. So we expect an array with we expect an object, with 2 arrays, one for the kids per household and one with the weight of all presents that will be delivered to that household, and the overall capacity that we can fit into the slate for one trip. Capacity is the weight that Slate can carry, excluding Santa. Okay, so we don't have to try to come up with some, random weight for Santa. That's good. When posting, the elves expect an HTTP status code of 200 to be returned, with a body detailing how many kids can be reached given the data set provided. Okay, and the response again should be an object with a property called kids, with a number that actually represents how many kids could be addressed with one trip. Also, the header in the response should contain content type application JSON. Note the above data is an example. The data used when submitting will be different values and length of arrays, but not huge. Okay, so I think that's the overall the requirements. My idea is to solve this challenge by using Rust. And with that said, I would jump straight into solving it by starting at the beginning. So I have already installed Spin on my machine. I've installed Spin 2.0.1 over here, which I can use to follow the instructions, like saying, hey, create a new application. And I think, Sohan, and you discussed this already with Mikkel in the last or the stream before, which template to pick. I'm in that team that chooses HTTP empty, because this allows me to structure the app, even if the app grows later on a little bit. It gives me the flexibility to structure the app as I wanted to.
Interesting. Radu, which one do you go with? I'm super curious.
Yeah, same. I start with an empty app, and then I add various components along. If my app ever extends beyond a single component, then I would basically do the same and create a directory for the source code and rearrange all of that. So my default is start with empty and then add components as I go along.
Okay. Folks in the audience, let us know what you do as well. Holy Odin, Bunny, David, others as well. Do you start with... Oh, okay. David also says he does HTTP empty. Oh, interesting. I feel I'm the only one who goes with the template and then starts adding components. So maybe I should also do the empty thing and try it out. Very cool. All right.
To be clear, this is just my opinion. There's no difference in how Spin works or how it executes anything. It's just, as developers who are very picky and very particular about the very unimportant things, and this is one of them.
But to be honest, it reminds me somehow to back to those days when I was using Visual Studio and I had to come up with a blank solution instead of creating a project that automatically somehow creates a solution. So at least for me, I feel like I have a little bit more control about what happens, right?
Okay. Okay. So Bunny's on my side. Thanks, Bunny. I know finally I have someone who's also doing HTTP and a language, but I'm going to try the HTTP empty for the next challenge, and we'll see how it goes.
Good. With that, yeah, so let's just go through those questions that were asked by the creating new application wizard. So basically the name of the overall application will be challenge 2. We skip the description for now. And what we will see, we will end up with a new folder, which is, it's quite, plain. So we just got a spin toml, just specifying the fundamental metadata of the application. And right now it's our task to come up with or to add those components that actually will address the needs or that we will use to address the requirements of challenge 2. And to do so, we can use a spin add. And again, that brings the selector for the template. And then I will go with HTTP Rust for now. And let's call this, because it's basically an API, I would go with API. Again, skip the description. And as we already, if we jump back to, I think it's 3, no, there we go. So we expect a post request to hit the root route. And what we can say right here in the wizard is we can instruct on which path, so the base path that the app should, or this component should be invoked, right? So we want this component to be invoked for all the requests hitting any endpoint in our application. So let's go with that. And right now, yeah,
sorry
we have
to interrupt,
yeah.
but can you
Sure.
increase your text size a little bit? Like maybe just zoom in a little bit. Yes, there we go.
Let's do a cat spin, because there's been a change, right? So I've used spin add to add my API component, which behind the scenes created like a Rust project that we will look into in a second. But it also extends the spin toml file by adding the trigger of type HTTP and pointing that one to our API component that we obviously have to write right now. Cool. With that said, I think we don't start a discussion about which IDE and which editor. So I also have...
No, we had like 45 minutes slotted just for that. No, I'm kidding.
No. Oh, good. So I would go with VS Code for now. Let's just move that to my second screen over here, and this one maybe to the third. And let's bump the font sizes again a bit. So... this is too big. I guess we have to rearrange a little bit. There we go. Is this okay, or should it also work, Son?
Yeah, that looks good.
Okay, cool. So now we're looking at the same folder basically in VS Code, and we can skim through our component that has been bootstrapped. So we find a default, so to say, Rust crate. Library crate that is configured, to compile down to WebAssembly over here in SpinToml. And we can actually jump right into implementing or solving the challenge. So maybe we can start by doing the or setting up the API that it reacts to the right requests, and then we can implement actually solving the challenge. So we have, all the API stuff addressed, and we could just use the rest of the time then to take care about solving the challenge. That said, I mean, the challenge isn't that complicated, so we don't need that much of handlers to address all the requirements. However, personally, I really love having that full-fledged router capability baked into Spin. So I would come up with my router over here just to be on the safe side, maybe to play around with things and register different routes, or maybe have one API to address multiple challenges. It gives me a little bit more flexibility, so to say. But we expect a post request hitting the root route, and then we want to solve our challenge, right? And finally, we have to come up with the result. It's basically an anyhow result that returns something that implements into response. again, router.handle returns a response, which obviously implements that trait. So this should be the overall routing capabilities to solve challenge 2. So we have to provide this one. Oops, let's do it over here. So we have.
So while you're doing that, Thurston, I have a
Yes.
question. I see Copilot keeps popping up and trying to offer very helpful suggestions.
Yeah.
How do you feel about that?
Well, I think my instance of Copilot gets better for me because I do a bunch of work with Spin, right? So it knows some personal preferences that I do, maybe from context, maybe by tracking my activity with Copilot. However, I don't use it every day because when exploring new things, my brain does not go into the learning mode because I'm just accepting what happens there. And if I lose access to Copilot at some point in time, I wouldn't feel that comfortable as if I came up with something on my own. So yeah, mixed feelings about Copilot so far. But if you find yourself in a position where you have to repeat or you have to do repetitive work, then it could be a performance booster, right?
Yeah. I was going to bring up writing unit tests and basically writing a boilerplate for unit tests.
Yeah.
I use it for that, and then I disable it right back.
Yeah. That's right. I mean, it heavily depends, right? So boilerplate, like, okay, what Copilot suggests right now looks maybe okay-ish, but it does not know about the crates I'm using. It does not know about what my intention currently is, right? Obviously, I could, add more comments and so on and so forth to make it smarter. But yeah, it's an on-off relationship, so to say, that I have with the Copilot. Yeah. Cool. Let me check. So basically, I think from a structural point of view, we should be cool. We have to do something over here, and then we have to bring in params, right? Import this one, yes. Okay, yeah, now it's complaining about the return value, but that should be good for now. Or maybe we have to return an okay. HTTP, let's stick with response builder status 500 for now. And I think we have to provide a body. Right? Yeah, and now just REST analyzer just complains about the unused variable. Okay. So with this in place, I've laid out already the API. I have my solve challenge handler, so to say, where we'll actually solve the puzzle in a minute. I can now. I would start thinking about the API contracts. So again, jumping back over here, we expect this structure as a payload, and this is fairly in Rust. It would be a fairly simple struct with just 3 properties. I would expect them right now to be regular unsigned integers. So we have kids, weight, and capacity. Let's go there. And we're just doing that in one file, although we can split and use multiple Rust files. Obviously, I will keep things simple for now. So let's say this is a request. Let's call it request model. So we have pub. We have kids, which is a vector. It's not easy. Of magnitude 8 for now. Then we have a weight of 8, and we have a capacity All right. So having those properties in place, so this is my outer-facing API model. This is how I typically try to treat APIs. I would come up with an internal model that gives me a little bit more flexibility. Because to solve the challenge, let's go back. So we know that, assuming that this one is correct, we know that 18 kids could be delivered with that particular trip, right? So those two arrays are in that particular structure. They are not connected to each other. It would make it would make solving the challenge easier if we could somehow connect, the first element of the kids vector with the first element of the weight vector. Although we could just, iterate through it by index and then expecting the other one to be there, I would decouple this and come up with my own, let's say, struct that gives me the flexibility to have just one struct that gives me the kids and weight that I can then use and work on that one. Because I would obviously sort it in descending order, which gives me 7, 6, 5, 4, 3, 2, and 1. If I then take 7, 6, 5, 4, then we are at 10. That's getting complicated, right? 13, no, that's right. 6, 13, 18, there we go. So at this point, I mean, it's somehow a little bit guessing, but writing some unit tests could easily streamline the process of coming up with a reliable solution, not just for this particular test data, maybe also for the test data that we can find over here in the test hurl file. So I would, going back to this one, let me copy this already, and let's go back to VS Code, and let's move on over here. So
While Thorsten's doing that, sorry, Thorsten, I'm just jumping in for a bit, but I just wanted to highlight a comment by David, which I thought was very nice, where David's saying, after I submitted the challenge, I spent 2 hours figuring it out, how the knapsack code from the code assistant worked, which I think was a very cool thing, where you've done like a challenge, you've been productive, you've written some code, and then you've gone back and sort of figured it out. I did the same as well, where I sort of got ChatGPT to help me write the actual algorithm and then did the spin stuff around it, because I don't have the coding skills figure that out. But yeah, it's very cool. So yeah, thanks for sharing, David. Thorsten.
Yeah, cool. So okay, with the outer-facing API contract, so to say, I would come up with my own model how to treat this set of data, right? And I guess delivery, where we have a number of kids, which is an U8, and we have a number weight, which is again a U8. This is like, in my mind right now, I could come up with a vector of those things. Then I always have the connection between the number or the amount of kids and the weight of the presents. And then I just have to sort it and to, poke around with the capacity until we are out of capacity. But to streamline that experience, I would use basic unit testing over here. So what we can do, we can say, if we are in a test execution context, we want to have the tests module over here, and yeah, their Copilot suggests a lot of things. So let's just accept the default and get rid of what's not in our mind right now. So I would come up with a solution with a solve, maybe a solve. Yeah, solve challenge test, that's okay. So as the challenge outlines, we will have a request model that pretty much looks like this. I'm reconfiguring my system. That's why the multi-line cursor does not work. Okay, so that's the actual payload that's mentioned in the challenge. Then let me scroll up a bit. So from here, I would say I expect I get an actual result by calling into my solve method, and somehow we have to, add access to the request model there. And let's say expected was 18, right? Over here, 18 kids should be the result. So let's go back and say expected 18. Let's just say assert equal actual and expected. So we have to make our test or to make the code actually compile, we have to come up with a solve method. We do that again in our regular scope or top level scope over here. And this would accept a model of type request model, and it has to return an U8.
How much do we want to go into the weeds of Rust ownership, Thorsten?
Not that much, because I mean, I would hand over ownership right now. There, I would just provide a reference over there, and because this one, I know it would not need ownership of that.
Yep.
Model. Yeah, it's just I don't want to jump into that one right now. Because Sohan or one of you said it's 45 minutes, right?
No, 45 minutes just for the editor debate.
Yeah, exactly. Okay, so now let's return one for now, or 118. That 18 that would actually make the test green at this point, but we have to come up with a solution for that. And as I said, I like to decouple, right, this model, so the outer-facing contract from the actual model. And to do the conversion, I came up with just implementing the from trait for the vector of delivery, which gives me then a sorted, or in my opinion, in my thought process, I said, okay, somehow I have to sort all those arrays or those delivery objects or instances that I will end up with in a descending order, right? To have a 7, 6, 5, 4, 3, 2, 1 kids and the corresponding weight in an ordered or in a sorted way.
So basically, you wanna go to the households with the most children first, because the goal is to maximize the number of children, or the most weight per household. What is the goal?
The goal is to go with those stops with the most kids first.
Right.
And take it from there, right? And then just go how many or how far in the array we can proceed and add, more and more delivery stops to that trip by just subtracting from the overall capacity, which is 120, down to almost 0 in that case.
Yep.
So that's the idea. Yeah. Exactly. So with that, I want to implement the from and we said we want to just use this one. Oh, this is pretty. Let's see what Copilot suggests over here. So implementing from that's obviously the signature is correct. So I mean, this is somehow kids iter, then it zips in the weight iter, then it maps by kids and weights and returns this. Okay, basically it's actually building what I want, but it's missing the sort piece, because I want this one to be sorted in descending order. So we have to instead of implicitly returning that one, we could say, give me stops equal this one. Oops, this one. So this one gives me basically unknown is not what I expect it to be. I have to type it, right? Delivery. All right, so I now have an unsorted vector of delivery instances, and I want to sort those. So I can just call, and that's why I make it mutable in the first place over here. So I can say, yeah, starts dot sort by. So we get A and B, oops, A and B, and we want them in descending order. So we say by the number of kids in that household, right? So we say, hey, compare B.kids to a reference of A.kids. That's right. And this one, I think it does not return anything, right?
Yeah,
No.
it sorts it in place.
Yeah, in place. That's why it's mutable, obviously. And then I have to, either do this one stops, or I can just, do implicit returning over here. And up with that one.
Is that another debate that we need to set some time aside?
Maybe. I love this one. It looks.
Yep.
You get quickly used to it, right?
Yep.
Yeah.
It is very rusty.
Okay, cool. So now we can look at our actual implementation, because right now we just returned 18, right? So we can say, let's call it again stops, which is we expect a vector of delivery, and we, by implementing from on the by implementing the from type, we get also access to the into method. So this is quite handy to do, transforming or massaging data around. So we have right now the stops in a descending order by the number of kids in that household, and we need the capacity, right? And the capacity is, we have that in our model, right? But we borrowed that. So I would come up with, and it's immutable by default. So we would say, would go with a mutable, let's say, remaining capacity, and also let mute, I would say, reached kids equals 0. And now we can simply, and Copilot again suggests something, we can simply iterate over that array once of delivery instances, and then just check if we have enough remaining capacity to fit, or to add all the presents for all the kids in that household to the slide, or if we already ran out of capacity. So this should be fairly doable, right? We can just say for stop in starts, if stop, let's do it. I prefer if remaining capacity is bigger than what is it? Stop dot wait. So if we have more capacity left, then the stop is actually would take capacity. Then we can say remaining capacity. We subtract the weight. We could then increase the number of kids that we've reached. If we, however, have, or if we stop on an, or if we look at an element with higher weight than remaining capacity, we break the for loop, and we basically could return reached kids over here. So to test this one, let's go back to the folder, to the API folder over here in terminal, and let's do I think we have to do cargo build first, or at least this, we have to do it at any point, right? Oh, error, could not compile.
Yeah, cargo build will default to attempting to compile your current target, which is...
Yeah, you're right.
No.
Let's do a spin build over here. And now it compiles it for the correct platform, right?
Also, folks, we dropped Challenge 3 earlier in the stream, so if you're just joining us, do check out Challenge 3. It has things to do with serverless AI, large language models, prompt engineering, all that fun stuff. Again, just check out github.com/fermyon/advent of spin, Challenge 3. And yeah, we're waiting for your responses. Got some amazing responses for Challenge 1 and 2, so really looking forward to it.
Okay, so in the meantime, I worked around my mistake by simply, let me put it on top of the screen. So I was in the API folder, right? This one is where my Rust library crate is. I went one folder up. This is where the spin pommel is, right? And the spin pommel has the command to build the crate for the correct platform, as Rado suggested. So I can do a spin build over here. It compiles, although there are some warnings, yes, we will address those. But then once I have compiled it once, especially the dependencies, I can move to API and I can do a cargo test over here, which executes the unit tests. I don't know if is there a smarter way to do that?
Integrating a strategy for unit and integration test is something that we've wanted to do for a long time. There is no current, like if you open the spin.toml file for a second,
yes,
spin.toml has a reference to how to build your component. So if there's a component build section that basically has the command to build it. We've been thinking for a while about what does testing look like in this world, and I could see a component.tests section that would contain basically the cargo test command or whatever other setup required to do testing, whether it's unit testing, whether it's other kind of testing. And so if people have thoughts and opinions about that, there might even be an open issue on the spin repo about how to do testing, but currently the way you've done it, by basically going into the component directory and just running the native test, is the way to go for now.
Okay, cool. But okay, so I have to look up for that, look for that issue, and to see what other people are trying to do, and yeah, maybe that's a good opportunity for all the attendees or the viewers of the stream to bring in their thoughts and their wishes, right? Okay, that said, let's sneak into the HURL files, right? So we can use HURL for testing. And the test HURL file, so I typically go to the raw representation over here, bring up the address bar, copy the address. Then I can move back to the nice visual representation again. And then I can just go to my terminal, go to where my spin app is and use it. wget to download the test HURL file. Then you go one up in your history of your terminal and you grab submit. And then we have all the HURL files in place that we need to test and to submit our challenge. But the test HURL file gives us, enough information to also test our algorithm, so to say. So the small solution I came up with different data. So we can come up with a second test and quickly, basically we can just copy the test, solve, and now naming things is hard. Solve another challenge, and let's grab this one.
While you're doing that, there are various ways in which you can have a single test function and basically have it execute different inputs to it. I think there's rtest, which is one of the popular Rust testing libraries, or literally just having multiple request models in the same function. But this is a very clean way of separating the two.
Yeah, that's great feedback. How's it called? rtest? Yeah, that's the one that I think that exists for almost every language with different names, right? That gives you the separation of test data and test execution, where you can just iterate through all your test data and have the same test execute multiple times. That's great. Great tip by Bunny. We can use a make file or whatever, mage or whatever, right? To to execute everything, to automate everything, right? That's right. That's great. Yeah, so definitely. I mean, adding the second test with the same test logic. And obviously, my test is this one is right. But what do we expect over here? So let's make this one 12. Okay, so this is the, let's say, the poor man solution that does not add that many dependencies or external dependencies to our simple project over here. All right, so having another test data, so to say, let's fire up the tests again. So let's do a spin. We can do a spin watch over here and just test it in a different instance of the terminal, right?
As a side note, cargo test will make sure to build again if anything changed.
Yeah, but then I had to provide the target architecture again to spin test, right?
No,
to cargo test.
Cargo tests will, this one, basically, if you think about it, it just executes because there's nothing WASM specific in your tests. It literally just tests logic that is compilable to your current target.
Yeah, that's right. That's right. All right, so both tests are green. That's great. That means we can look into wiring up the things, right? So because right now we have that tested solve function over here, but as you can see, function solve is never used because we simply return HTTP 500 for every incoming call so far. So let's change this and wire up the things. So let's look at the request body by going there and saying request body, and let's clone this thing for now. And right now I would use 30 JSON. That's right. But I haven't installed it yet as a dependency. So let me quickly add this one, cargo add 30 JSON. There we go. So I would say we want an instance of our model that's 30 JSON from slice. That looks good. If it can't, it has to. It's the error, right? Okay. I have not added the macros over here, so let's cargo add 30. Add 30 fderive. So now, because right now 30 JSON doesn't know how to construct an instance of the request model, so we can go to the request model, which is way there, and we have to derive it. And I like it this way. And once we're here, we can do some housekeeping. There should be more traits that should be implemented on every struct, but again, don't let us go down that rabbit hole. This one, what's over here? The call to clone reference is a string to not using. Okay, we'll look into that in a second.
If you hover over the body function, it already returns a reference to a slice, which means it does.
Okay, so it can just get rid of this one. Right, because that that makes sense. I'll change this to we can. We just need P for coming up with a model instance. That's right. So we don't have to hand over the reference over there. And finally, I would go with reached kids would be solve and solve a reference to our model. This we would end up with 18 for the outlined example as just an U8, Yeah, for U8. But we have to return to revisit this one. Let's go there. We have to return again a JSON. We have to set the HTTP header on the response. We have to return status code 200, and we have to return the response as an object with the kids property instead of creating another struct and maybe returning an instance of that struct. If the struct consists of just one property, I use the JSON macro provided by Cerdy.json that allows me to quickly do something like this: result equals JSON exclamation mark. So this gives me once I brought this into context, this gives me the result as a JSON object, right? So I can just construct the response using that inline type, so to say. But again, that's personal preference. I use it just for structs that would consist of a single property. And now let's get rid of what we've used there. Again, 200 over here. We have to add a header, which is content type. And there we go with application JSON here. And we provide result to string. So this, I guess, should address all the requirements. So again, let's go to terminal. Let's do so here with our spin toml. Let's do a spin build to ensure Torsten didn't mess up the things on the last mile. That looks good. So we can do a spin up.
No pressure, Torsten. No pressure.
All good. We can do a spin up, but I forgot to start tmarks, right? Okay, so we can do a spin up over here, which gives me a new tab, and I could just have the test hurl file. Now I have to double check. It's hurl. Is it test? No, it's test.
Yep.
And then test hurl. So the hurl CLI, I installed it via Homebrew, but hurl.dev, that's the URL, and there you can find detailed installation instruction. And the CLI basically, that basically has activate test mode, and then as an argument, you have to point to your test hurl file. So we can basically say hurl test hurl. Yay! Great. Yeah, I mean, basically we grabbed already the test data from test hurl and verified our implementation by using a unit test. Yeah, so that was my my way of approaching challenge 2, and yeah, maybe there are more idiomatic ways how to solve it, but at least it helped me, having the confidence that quote algorithm was correct, that had me solving the challenge.
Yeah, this was great. I really particularly appreciate the setting up the tests suite and the writing the 2 test cases and making sure that if we want to refactor, for example, and for example come up with a different strategy for how to solve it, we could at any point figure out if we messed up the implementation. And so I really appreciate the showing us how to do the test cases and the test infrastructure for this.
Yeah, cool. Yeah, I think the one of the, I mean, what I always try to apply when structuring things like that is to divide, let's say, maybe networking or the API layer from the logic layer over here. I mean, there's room for improvement, obviously, because instead of handing over the API model to solve, it would make way more sense to hand over a pointer to the back of delivery struct, right? Because this is the internal model. That makes more sense. So, but,
yeah, and this is something that I've been playing around with. I've been doing. I'm like 8 days behind on Advent of Code this year, and basically I'm trying to follow the same approach. And it's, as always, I find this type of challenge really, really good way of learning how to use a tool, a language, a combination of tools and languages. And I'm really, really appreciative of whenever I see people's approach on how to solve a problem. So this was great. Really appreciate walking us through this, Thorsten.
Yeah, thank you. Although I was really fighting my silent keyboard, because I heard your keyboard at the beginning of the stream, and I swapped mine. So I have a drawer over here with a bunch of mechanical keyboards.
I mean, half of the joy of getting someone on stream is hearing the clack. So don't do that again.
Okay, I know that for next time right now.
Yeah, next time we could basically go through a showcase of keyboards.
Oh.
Mine is not as fancy as yours, but to be honest, how long did it take to get used to typing on that custom setup?
Oh, quite a bit. It was a very good excuse for a few months of not being able to take notes in meetings because I would literally 20 words per minute.
Okay, yeah. I always wonder how one would, sneak that into a regular workday. That's I can imagine that's challenging. Yeah.
I actually did a bunch of consecutive weekends of typing practice.
Yeah.
Anyway,
That's great. That's great.
Nice. Thorsten, people appreciating your demo, and Bunny, Holy Odin, David, everyone else watching, appreciate you all for spending your time with us. I also think it was a great demo because, like Radu said, there are so many different ways to approach the same problem. So when you're doing Advent of Spin, Advent of Code, or just general problem solving in code, I think these are some of the ways that you can actually look at it. Reminder again, challenge 3 is up. This time it has to do with serverless AI. There's a lot of prompt engineering in this particular one. Extra points for creativity as well. So spend some time over the next week doing that. And again, there are prizes too. So check it out. Any last words, Thorsten, Radu, before we call it a day?
No, just a reminder that the fanny pack and then the beanie next week. Keep an eye out for those.
Yeah, and don't forget to post your stories to Discord, right? Because we all want to read through them. So that's definitely that would definitely be cool. Yeah.
Yeah, we're definitely going to do a stream where we look at the submissions as well. Maybe the last one, which is next week, and that should be fun. So I'm looking forward to that too. All right. Again, big thanks to all of y'all for watching and staying with us for the last hour or so. We really appreciate it. Go check out the Challenge 3, and we will see you next week, same time, same place. See you soon. Bye.
Bye.